In this video, I'll share 101 space facts, not just for entertainment, but to give us all a reason to look up, wonder, and remember the mysteries still waiting beyond our world.
So many questions. Why is the world spinning? Why is the moon keeping its orbit? Can rockets fly backwards? The facts you didn't know you needed. The Useless Show.
Space doesn't have a definitive starting point above Earth, but a commonly accepted boundary is the Kármán line, located at an altitude of 100 kilometers. This imaginary line is often used by experts to distinguish between Earth's atmosphere and outer space, providing a useful benchmark for spaceflight and aerospace endeavors. The temperature in the vast emptiness of space is incredibly cold, hovering around -270.45 degrees Celsius. This extreme chill is due to the lack of matter to absorb and retain heat, making space a truly frigid environment where temperatures approach absolute zero, the theoretical lowest possible temperature. Space is essentially a hard vacuum, meaning it's a void with very little matter. Unlike what you might picture, it's not completely empty, but the particles are so spread out that it creates an environment vastly different from anything we experience on Earth. There's no sound in space because molecules are simply too far apart to transmit sound waves effectively. On Earth, sound travels through vibrations in air molecules. In the vacuum of space, with incredibly few molecules, there's nothing for those vibrations to travel through, resulting in an eerie absolute silence. Even the space between galaxies isn't entirely empty. It contains an average of about 1 atom per cubic meter. While this might seem insignificant, over the immense distances between galaxies, these scattered atoms contribute to the overall composition of the universe, illustrating that even vast voids hold a tiny bit of matter. Our home galaxy, the Milky Way, is a truly massive structure, estimated to contain between 100 and 400 billion stars. To put that in perspective, that's a staggering number, representing countless suns and potentially billions of planetary systems, all swirling together within our cosmic neighborhood. The universe is observed to be approximately 13.8 billion years old and has been continuously expanding since its formation in the Big Bang. This expansion isn't just objects moving apart within space, but space itself stretching, carrying galaxies and all their contents further and further away from each other over cosmic time. Within the observable universe, there are an estimated 2 trillion or 2,000 billion galaxies. This incredible number highlights the immense scale of the cosmos, with each of these galaxies containing billions, if not trillions, of stars, planets, and other celestial bodies far beyond what we can currently see or comprehend. The International Space Station, or ISS, stands as the largest crewed object ever put into space. This collaborative effort among multiple nations serves as a unique orbiting research laboratory, where astronauts conduct experiments and gather data in microgravity, pushing the boundaries of human exploration and scientific discovery. Spacecraft have successfully visited all the known planets in our solar system, providing us with invaluable data and stunning images. From the fiery surface of Venus to the icy moons of the outer planets, these missions have dramatically expanded our understanding of our cosmic neighborhood and the diverse worlds within it. Mercury and Venus are unique among the planets in our solar system because they are the only ones without any moons. All the other planets, including Earth, have at least one natural satellite orbiting them, making Mercury and Venus stand out in their solitary journeys around the Sun. Our solar system is home to a surprising number of natural satellites, with over 219 confirmed moons orbiting its planets. These diverse celestial bodies range in size from small, irregularly shaped rocks to worlds larger than some planets themselves, each with its own unique characteristics and often surprising features. It might seem counterintuitive, but some moons in our solar system are actually larger than the planet Mercury itself. For example, Jupiter's moon Ganymede and Saturn's moon Titan both dwarf Mercury, showcasing the incredible diversity in size and composition among the celestial bodies orbiting our Sun. When a star ventures too close to a black hole, it faces an incredible gravitational force that can actually tear it apart. This phenomenon, known as tidal disruption, happens as the black hole's immense gravity stretches and rips the star, creating a spectacular burst of energy and light that astronomers can detect. Astronomers closely observed a star orbiting the Milky Way's central black hole for 20 years, providing incredible insights into the immense gravitational forces at play. This long-term study allowed scientists to precisely track the star's movements, confirming predictions about black hole behavior and shedding light on our galaxy's core. Gravitational redshift is an intriguing phenomenon that occurs when a star's light loses energy as it attempts to escape the powerful gravitational pull near a black hole. The light waves are stretched, shifting towards the red end of the spectrum, providing direct evidence of the intense gravity in these extreme cosmic environments. Venus holds the title for the hottest planet in our solar system, despite not being the closest to the Sun. Its scorching surface temperature of 864 degrees Fahrenheit or 462 degrees Celsius makes it an incredibly inhospitable world, far hotter than even Mercury, the innermost planet. Venus's extreme surface temperature, reaching 864 degrees Fahrenheit, 462 degrees Celsius, is a result of a runaway greenhouse effect. This intense heat traps much of the Sun's energy within its dense atmosphere, making Venus a perpetually scorching and inhospitable world quite different from our own. Our solar system is approximately 4.571 billion years old. This age is determined by dating the oldest meteorites, which are remnants from the early solar system's formation. This vast time scale highlights the immense period over which our Sun, planets, and all the celestial bodies within our system have evolved. The Sun is destined to undergo a monumental transformation. In about 5 billion years, our star will evolve into a red giant, expanding significantly and becoming much cooler in its outer layers. This phase marks a crucial stage in its life cycle as it exhausts its core hydrogen fuel and begins fusing helium. Looking even further ahead, approximately 7.5 billion years from now, the Sun's continued expansion as a red giant will lead to it engulfing Earth. While it's a distant future, this event highlights the dynamic and evolving nature of stars and their profound impact on planetary systems. Enceladus, one of Saturn's moons, possesses an incredibly reflective surface, bouncing back an astounding 90% of the sunlight that hits it. This remarkable reflectivity contributes to its extremely low temperatures. The icy exterior keeps Enceladus frigid, with its surface temperature plummeting to about negative 394 degrees Fahrenheit. Mars is home to Olympus Mons, the tallest mountain known in our entire solar system. This colossal shield volcano towers an incredible 16 miles, 25 kilometers high. To put that into perspective, Olympus Mons is nearly 3 times taller than Mount Everest, the highest peak on Earth, showcasing the immense geological scale found beyond our planet. Adding to the impressive statistics of Olympus Mons, its base stretches across an area comparable to the entire state of Arizona. This makes it not only the tallest, but also one of the widest mountains in the solar system, demonstrating the sheer magnitude of Martian geological features. The Whirlpool Galaxy, also known as M51, holds a significant place in astronomy as the first identified spiral galaxy. Its beautiful and distinct spiral arms are not just for show, they are active regions where cosmic gas and dust compress, leading to the vigorous birth of new star clusters. A light year is a fundamental unit in astronomy, representing the vast distance that light travels in one Earth year. Light itself moves at an incredible speed, approximately 300,000 kilometers per second. This makes 1 light year an enormous measurement, roughly equivalent to 5.9 trillion miles. Our home galaxy, the Milky Way, spans an immense distance of 105,700 light years across. To comprehend its scale, consider this. If a spacecraft were capable of traveling to the Milky Way's center, it would take an astonishing 450 million years to complete the journey, emphasizing the sheer vastness of our galaxy. The Sun is a truly massive object, weighing an astounding 330,000 times more than Earth. Its sheer bulk is a testament to its gravitational dominance in our solar system. This immense mass is what allows it to hold all the planets, including Earth, in orbit around it. When it comes to size, the Sun's diameter is a staggering 109 times larger than Earth's. To truly grasp this difference, consider that approximately 1.3 million Earths could comfortably fit inside the Sun. This illustrates the immense scale of our star compared to our planet. The greenhouse effect on Venus is incredibly strong, effectively trapping heat across the entire planet. Its thick atmosphere, primarily composed of carbon dioxide, acts like a blanket, preventing heat from escaping into space and leading to the scorching surface temperatures that make Venus the hottest planet in our solar system. The Sun is the dominant body in our solar system, making up an overwhelming 99.85% of its total mass. This incredible concentration of mass means that all the planets, asteroids, comets, and other celestial bodies combined account for a tiny fraction of the solar system's overall weight, highlighting the Sun's centrality. On the Moon, the footprints left by astronauts during the Apollo missions will remain indefinitely. This is because there is no wind or atmosphere on the lunar surface to erode or disturb them, preserving these historical markers for countless millennia. When the American flag was planted on the Moon during the Apollo missions, it appeared to be blowing in the wind. However, this was an optical illusion. The flag was actually held unfurled by a horizontal support rod sewn into its top edge, creating the appearance of movement in the airless vacuum. When standing on Mars, a 220-pound person would experience a significantly lighter sensation, weighing only 84 pounds. This difference is due to Mars's weaker gravitational pull compared to Earth's. Mars's weaker gravity is a huge advantage for scientists. It allows them to load their rovers with more equipment than they could on Earth. This means more scientific instruments, more sensors, and more tools to explore the Martian landscape. The less gravity there is, the more payload the rovers can carry, leading to more comprehensive data collection and a deeper understanding of the red planet. Jupiter is home to an astonishing number of moons, with 79 currently identified. Among this vast collection, one stands out: Ganymede. This colossal celestial body isn't just Jupiter's largest moon, it also holds the title of the largest moon in our entire solar system. To put its size into perspective, Ganymede is actually bigger than the planet Mercury, making it a truly remarkable object in space. The Martian day is surprisingly similar in length to an Earth day, lasting 24 hours, 39 minutes, and 35 seconds. However, a year on Mars tells a different story. It stretches out to a lengthy 687 Earth days, meaning that one trip around the Sun for Mars takes nearly twice as long as it does for our home planet. This difference in orbital period significantly impacts the Martian seasons and climate. NASA's LCROSS mission made a groundbreaking discovery: evidence of water on the Moon. This wasn't just a faint trace. The mission provided strong indications that water ice might be preserved in areas of the Moon that are perpetually shrouded in shadow, specifically within craters at its poles. These permanently shadowed regions offer a cold, stable environment where ice can survive for extended periods, making them prime targets for future exploration. The Sun, the center of our solar system, doesn't rotate as a solid body. Instead, its rotation period varies depending on the latitude. At its equator, the Sun completes a rotation once every 25 Earth days. However, as you move towards its poles, the rotation slows down, taking up to 35 Earth days. This differential rotation is a fascinating characteristic of our star, influencing its magnetic field and solar activity. Earth holds a unique distinction among the planets in our solar system. It's the only one not named after a god. Its name, Earth, has humble origins, stemming from Old English and Germanic words that simply mean ground or soil. This contrasts with planets like Mars, named after the Roman god of war, or Jupiter, named after the king of the Roman gods, highlighting Earth's distinct linguistic heritage. The tides we observe on Earth are a direct result of the gravitational pull exerted by both the Moon and the Sun. The Moon, being much closer, has a more significant influence on Earth's tides, creating 2 high tides and 2 low tides each day. The Sun also contributes, though to a lesser extent, either amplifying or moderating the Moon's tidal effects depending on their alignment, leading to spring and neap tides. I'd love to hear which fact stood out. Leave the number in the comments so others can find it too. Pluto, once considered the 9th planet, is surprisingly small. In fact, it's smaller than the continental United States. To give you a better sense of its scale, if you were to walk around Pluto's equator, the distance covered would be roughly equivalent to traveling from London to Denver. This comparison really puts into perspective just how diminutive this distant dwarf planet truly is. White holes are fascinating theoretical objects that represent the opposite of black holes. While black holes are regions of space-time from which nothing, not even light, can escape, white holes are hypothesized to be regions into which nothing can enter, but from which matter and light can escape. They are often discussed in the context of general relativity and are intriguing concepts that push the boundaries of our understanding of the universe. Venus is an extreme planet, boasting more volcanoes than any other planet in our solar system, with over 85,000 identified. One of its most prominent volcanic features is Mont Mons, a colossal volcano that stands an impressive 5 miles, or 8 kilometers, tall. This makes Venus a world of intense geological activity, with its surface shaped by countless eruptions over its long history. Uranus, one of the solar system's ice giants, has a distinct blue glow thanks to the methane present in its atmosphere. This methane plays a crucial role in how Uranus appears to us. It effectively filters out red light from the sunlight that hits the planet, while simultaneously reflecting blue light. This process gives Uranus its characteristic serene blue hue, making it a visually striking member of our planetary neighborhood. Jupiter, Saturn, Uranus, and Neptune are collectively known as the gas giants. Unlike the rocky planets like Earth, these colossal worlds are made primarily of hydrogen and helium, the two lightest and most abundant elements in the universe. They lack a solid surface and are instead composed of dense, swirling atmospheres that gradually transition into liquid and then metallic forms of these gases deep within their interiors. Uranus has a fascinating collection of 29 known moons. Among them, Titania stands out as the largest. This icy satellite is not only the biggest moon orbiting Uranus, but also holds the impressive title of the 8th largest moon in our entire solar system. Its considerable size and icy composition make it a significant object of study for astronomers interested in the outer solar system. A single season on Uranus is incredibly long, lasting approximately 21 Earth years. This extended duration is due to Uranus's extreme axial tilt, which causes one pole to be pointed towards the sun for an extended period, followed by the other pole. This results in incredibly long, continuous periods of daylight and darkness at the poles, creating seasons that are unlike anything experienced on Earth. A day on Uranus is surprisingly short, lasting just 17 hours, 14 minutes, and 24 seconds. Despite being an ice giant, its rotational speed is quite fast, completing a full spin on its axis in less than an Earth day. This rapid rotation contributes to its unique weather patterns and overall atmospheric dynamics. Neptune's largest moon, Triton, has a unique characteristic. It orbits in reverse, which is known as a retrograde orbit. This suggests that Triton was likely captured by Neptune's gravity rather than forming alongside the planet. Eventually, Neptune's powerful tidal forces will tear Triton apart, creating a spectacular new ring system around the gas giant. This process will take millions of years, but it's a fascinating glimpse into the long-term evolution of celestial bodies. Space is home to an incredible number of stars. In fact, there are more stars in the observable universe than there are grains of sand on all the beaches of Earth. To put this into perspective, our universe is estimated to contain about 70 sextillion visible stars, a truly mind-boggling figure. Neptune, the most distant planet from the Sun in our solar system, takes an incredibly long time to complete one orbit. A single year on Neptune lasts a staggering 165 Earth years. This extended orbital period highlights the immense scale of our solar system and the vast distances involved in planetary motion. Pluto's largest moon, Charon, is quite substantial, being roughly half the size of Pluto itself. This makes the Pluto-Charon system unique, often referred to as a binary system rather than a planet and its typical moon. They are so closely matched in size that their gravitational interactions are truly remarkable. Pluto and Charon share a special bond. They are tidally locked. This means that both celestial bodies always show the same face to each other as they orbit a common center of mass. The International Space Station, or ISS, stands as the largest manned object ever launched into space. It's an incredible feat of engineering, stretching 109 meters long, which is roughly the length of an American football field. The ISS serves as a unique orbiting laboratory and a testament to international collaboration in space. On Pluto, a single day is considerably longer than an Earth day, lasting approximately 153.6 hours. This means that if you were to stand on Pluto, you would experience a very slow rotation, with sunrise and sunset separated by more than 6 Earth days. This contributes to the unique conditions on the distant dwarf planet. Saturn is a true giant in our solar system, holding the title of the second largest planet. While its impressive radius is 9 times that of Earth, its overall mass is surprisingly light. Despite its massive size, Saturn's density is only about 1/8 that of Earth, making it less dense than water. In the vacuum of space, free-floating liquids behave differently than they do on Earth. Due to the principle of surface tension and the absence of strong gravitational forces, any free-floating liquid will naturally form a perfect sphere. This phenomenon can be observed in water droplets on the International Space Station. Our solar system's inner planets consist of Mercury, Venus, Earth, and Mars. These rocky planets are located closer to the Sun and orbit within the asteroid belt, a region filled with numerous irregularly shaped asteroids. Their proximity to the Sun gives them distinct characteristics compared to the gas and ice giants further out. Our knowledge of planetary surfaces varies significantly. We've managed to map 100% of the surfaces of Mars and the Moon, providing detailed topographical data. However, despite living on Earth, we've only explored and mapped about 5% of our own planet's vast oceans, highlighting the immense mysteries still hidden beneath the waves. The Black Arrow rocket holds a special place in British space history. It was the only rocket ever successfully launched by Britain to deploy a satellite into orbit. This achievement marked a significant milestone for the UK's space program, demonstrating its capabilities in satellite deployment before the program was eventually discontinued. The universe is largely made up of things we can't see directly. Only about 5% of the universe is composed of visible matter, which includes everything from stars and planets to galaxies. The vast majority, a staggering 68%, is dark energy, and another 27% is dark matter, both of which remain mysterious to scientists. Light from the Sun, traveling at an incredible speed, takes approximately 8 minutes and 20 seconds to reach Earth. This means that when you look at the Sun, you are seeing it as it was over 8 minutes ago. This time delay highlights the immense distances involved in our solar system. At any given moment, our planet experiences a remarkable display of atmospheric activity. On average, there are about 2,000 thunderstorms occurring simultaneously across different regions of Earth. This constant electrical activity plays a crucial role in the planet's weather patterns and energy distribution. The Earth's rotation is slowing down, but don't worry, it's not something you'll notice in your lifetime. This deceleration is incredibly gradual, happening at a rate of milliseconds per century. It's due to the friction from ocean tides, which are created by the gravitational pull of the Moon and the Sun. Saturn's rings are an incredible sight. They stretch out an astounding 175,000 miles, making them wider than several planets combined. However, despite their immense length, they are surprisingly thin, measuring only about 3,200 feet from top to bottom. This gives them a delicate, almost ethereal appearance. Space officially begins about 62 miles above Earth, a boundary known as the Kármán line. This imaginary line is often used to define where Earth's atmosphere becomes too thin to support aeronautical flight, marking the point where aerospace begins. Beyond this point, traditional aircraft can't fly effectively. The International Space Station, or ISS, is a remarkable feat of human engineering. It orbits our planet at an incredible speed, completing a full circle around Earth approximately every 92 minutes. This means astronauts aboard the ISS witness about 16 sunrises and sunsets every single day. Stars appear to twinkle to us on Earth because of our planet's atmosphere. As starlight travels through the various layers of air, it gets bent and refracted. This constant movement and density changes in the atmosphere cause the light to shimmer, giving the illusion of twinkling. We always see the same side of the Moon, a phenomenon known as tidal locking. This happens because the Moon's rotation period is exactly the same as its orbital period around Earth. Over billions of years, Earth's gravity has slowed the Moon's rotation until this perfect alignment was achieved. When we talk about galaxies, there are 3 main types you'll encounter: elliptical, spiral, and irregular. Spiral galaxies like our own Milky Way have distinct arms swirling around a central bulge. Elliptical galaxies are more spherical or oval, while irregular galaxies lack a defined shape. Our home galaxy, the Milky Way, is truly massive. It's estimated to contain approximately 100 billion stars, each a unique celestial body. From tiny red dwarfs to colossal blue giants, this vast collection of stars creates the luminous band we can see across the night sky. While the Milky Way is enormous, the IC 1101 galaxy takes scale to a whole new level. This supergiant elliptical galaxy is believed to harbor an astonishing 100 trillion stars. To put that in perspective, that's 1,000 times more stars than what's in our entire galaxy. With the naked eye, under optimal conditions, we can typically see between 3 and 7 galaxies from Earth. The most famous and easily visible is the Andromeda Galaxy, which appears as a faint, fuzzy patch in the night sky. Other visible galaxies vary depending on light pollution and location. In 2016, scientists made a groundbreaking discovery when they detected a radio signal that originated 5 billion light-years away. This incredible signal provides a glimpse into the universe's distant past, offering clues about cosmic events that occurred when the universe was much younger. The Andromeda Galaxy is our closest galactic neighbor, located approximately 2.5 million light-years away from Earth. It's on a collision course with our Milky Way. But don't worry. This cosmic encounter won't happen for another few billion years, creating a spectacular new galaxy. The first supernova observed outside our own galaxy was a momentous astronomical event that occurred in 1885. This powerful stellar explosion was detected in the Andromeda Galaxy, providing early evidence that supernovas are not unique to the Milky Way, but are a universal phenomenon. The first black hole ever photographed, Sagittarius A star, is truly colossal. Located at the center of our Milky Way galaxy, it's estimated to be about 3 million times the size of Earth. Its incredible gravitational pull is so strong that not even light can escape its grasp. The distance between the Sun and Earth is defined as 1 astronomical unit, or AU. This measurement is roughly 93 million miles. The AU is a fundamental unit in astronomy, used to measure distances within our solar system and to express the vast scales of space. Here's a fun and unexpected fact. Buzz Aldrin, the second person to walk on the moon, had a mother whose maiden name was Moon. This remarkable coincidence adds a whimsical touch to the history of space exploration and his personal journey to the lunar surface. Buzz Aldrin, originally named Edwin Eugene Aldrin Jr., legally changed his first name to Buzz in 1988. He had been using the nickname since childhood, inspired by his younger sister's mispronunciation of brother. It became so iconic that he officially embraced it. On Venus, the conditions are truly extreme. It's a planet where it literally rains sulfuric acid, a corrosive substance that would be lethal on Earth. Even more bizarre, the planet's intense atmospheric pressure and high temperatures can cause certain metals to vaporize and then snow down onto the surface. In 1997, 3 men from Yemen actually attempted to sue NASA. Their claim was that NASA was trespassing on Mars, as they believed the planet was inherited from their ancestors. This unusual lawsuit highlights some unique perspectives on celestial ownership, showcasing a truly out-of-this-world legal dispute. Standing at an incredible 21 kilometers high and 600 kilometers wide, Olympus Mons on Mars holds the title of the largest mountain in our solar system. To put that into perspective, it's nearly 3 times taller than Earth's Mount Everest, making it a truly colossal geological feature on the Martian landscape. The atmospheric pressure on Mars is incredibly low. In fact, it's so minimal that if a human were exposed without a spacesuit, their blood would immediately boil and form bubbles. This extreme condition would unfortunately lead to instant death, emphasizing the vital importance of protective gear for any Martian exploration. Mars possesses about 37.5% of Earth's gravity. This means that if you weigh 100 pounds here on Earth, you would only weigh about 39 pounds on Mars. This significant difference in gravitational pull would make for a very different experience of movement and daily life compared to what we're used to. Scientists have given informal names to many Martian rocks they've discovered. These informal labels help researchers identify and refer to specific rock formations, adding a touch of personality to the scientific exploration of the red planet. If you'd like more hour-long collections like this, tap subscribe. I keep it simple. One deep Adlight session each week. Saturn's North Pole features a truly remarkable and persistent hexagon-shaped jet stream. This incredible atmospheric phenomenon is approximately 32,000 kilometers wide, with winds raging at speeds up to 320 miles per hour. It's a stunning example of complex weather patterns on other planets. Saturn holds a unique distinction among the planets. It would actually float in water. This is due to its remarkably low density of 0.678 grams per cubic centimeter, which is less than water's density of 0.998 grams per cubic centimeter. This makes Saturn the least dense planet in our solar system. Triton, one of Neptune's 13 moons, is an incredibly cold place. Its average surface temperature hovers around a frigid minus 391 degrees Fahrenheit, making it one of the coldest known objects throughout our entire solar system. This extreme cold is a testament to its distant orbit from the Sun. The word astronaut has fascinating origins stemming from ancient Greek. It's derived from two words, astron, meaning star, and nauts, meaning sailor. When combined, they beautifully translate to star sailor, perfectly encapsulating the adventurous spirit of space exploration. Apollo astronauts Neil Armstrong, Buzz Aldrin, and Michael Collins faced a unique challenge before their historic mission. They had no life insurance. Instead, they pre-signed numerous photographs. The plan was that if they didn't return from the mission, these signed photos would be sold to provide for their families. The beloved Toy Story character Buzz Lightyear actually owes his name to a real-life space hero. He was named after Apollo 11 astronaut Buzz Aldrin, who was the second person to walk on the moon. This tribute connects a classic animated character to a monumental achievement in human history. A NASA spacesuit is an incredibly complex and expensive piece of equipment. Each suit costs approximately $12 million, reflecting the advanced technology and specialized materials required to protect astronauts in the harsh environment of space. It's a significant investment in human exploration. Inside an astronaut's helmet, you'll find a rather practical and unexpected item, a Velcro patch. This patch serves a simple yet essential purpose, as a scratcher. It allows astronauts to relieve an itch without needing to remove their helmet, a small but important detail for comfort during long missions. The first living creatures ever sent into space were fruit flies, back in 1947. Remarkably, these tiny insects survived the flight, paving the way for future biological experiments beyond Earth's atmosphere. This early mission was a crucial step in understanding how living organisms react to space travel. In 1949, a rhesus monkey named Albert II was sent into space. Unfortunately, his mission ended tragically when his parachute failed upon re-entry, and he did not survive. This early attempt at sending larger animals into space highlighted the significant risks involved in pioneering spaceflight. Laika, a stray dog from Russia, holds a significant place in space history as the first dog to orbit Earth. While her journey marked a major milestone, it also sadly ended in tragedy. Laika died from overheating during the mission, highlighting the challenges of early space exploration. Space is a nearly perfect vacuum where sound cannot travel because it needs a medium like air or water to propagate. Despite this silence, space contains water in the form of ice and vapor, and is home to billions of stars and galaxies spread across the vast cosmos, making it rich and diverse. NASA has been exploring innovative solutions for long-duration space missions, and one fascinating project involves a three-dimensional printer. This advanced printer is specifically designed to create pizza for astronauts. The aim is to provide more varied and potentially fresher food options for crews on extended journeys, enhancing their comfort and nutrition far from Earth. That wraps up our journey through 101 space facts. Usually, I share random knowledge from everywhere, but today, we stayed focused on the universe itself. And I hope you enjoyed the change. If you found even one fact that sparked your curiosity, then this hour was well spent. Thanks for watching, and I'll see you next time with more useless knowledge worth remembering.